first, let me just say, I almost feel bad for interrupting. I was so engrossed in that presentation that I had to scramble at the last minute to remember that I was next.
Oh, that's great.
Thanks so much, Heather. So today we'll be talking about roadside gardens as a solution to toxics in fish. Yes, I will share my webcam. Here we go. Oh,
Perfect.
oh no. Oh shoot, hold on. I'm sorry, I need to.
That's okay. Take a minute.
I am very sorry, but I am very used to doing this on Zoom, and I think that I got a little bit cocky.
How about I do your...
There's always technical difficulty for all of us, myself included. So this is part of the human aspect.
I could do the introduction while you're doing that, David, and do your bio. How's that?
Yeah, go for it.
Good. Hey, yeah. So yeah, I want to just introduce David. He's somebody I've worked with the last few years. Does a great job. He's the project manager for Snohomish Conservation District's community conservation team. Dave's worked in green stormwater infrastructure for several years and in community-led urban green space projects, and for several more years. He's worked as a project manager and administrator for the majority of his career to direct and support environmental studies and restoration projects in government and nonprofit sectors. His background is in environmental science, green infrastructure, with degrees and certifications from the University of Washington and Oregon State University. And again, I've worked with David on multiple projects and had multiple conversations, and he just does a great job, takes charge, always does everything he says he's going to do, and is an excellent partner with all of us in conservation. So David, I'm going to turn it over to you.
Well, David, thanks so much. I wish my webcam wasn't on so you all couldn't see me blushing. It's a very, very lovely introduction. Bill contacted me a few months ago and said, you know, we're coming up with this new information about toxics in fish, specifically 66P. I always get it backwards. But the tire rubber toxin. And he knew that we had been working on some roadside gardens and trying to do some things a little bit different with right-of-way gardens. He asked me if I would come talk about our experiences and how it connects to toxics in fish. So that's what we're going to discuss today. We're going to be discussing primarily a very specific kind of stormwater installation and things specific to toxics in fish. I'm going to give you a warning right now. I am not an organic chemist. I am barely even really a stormwater engineer or planner. I am an infrastructure planner and a stormwater planner. So I really want folks to ask questions, but I may not be able to answer some of them. And I will definitely refer you instead to the literature that I pulled to get some background on this. So first, for those not familiar with the community conservation team under Snohomish Conservation District, we do a number of different things. Today we are going to focus on green stormwater infrastructure, but we have a lot of love for all of these other sectors. So if you want to ask questions about those, I'd be happy to answer those too. And this is just because we're not in the same room, and I know that I'm fairly new, so some of you still may be getting to know me. I wanted to flex my Northwest credentials by showing this picture of me doing a bioswale planting in Bothell, wearing not one but two types of flannel, just in case anybody was concerned that I wasn't from the Pacific Northwest. So anyone not familiar with stormwater, we're going to do a really quick high-level 100-level survey of stormwater. Rainwater. Rain falls from the sky and it hits a surface. If that surface is impervious, as it is in most of our cities and communities, it results in predominantly runoff, a small amount of evapotranspiration, and very little infiltration. Most of it runs off. It runs over what's called pollutant generating surfaces that either then will enter a CSO, a wastewater system, to go and be treated, which of course may overwhelm those systems as they do in CSOs and CSO events. CSO, by the way, stands for combined sewer overflow. Or in some cases, they stay where they are, causing flooding, or they discharge directly to a waterway via a stormwater path, and they cause flooding and pollutant in that waterway. So GSI, Green Stormwater Infrastructure, is an attempt to get back to the pre-development type of stormwater, where there is a very small amount of runoff, and there is primarily evapotranspiration through plants and surface storage and infiltration. So stormwater and pollutants, as I mentioned, stormwater will run off into a number of waterways. And when they do that, they will cross pollutant generating surfaces. Those are primarily roads and sidewalks, though they also happen to cross turf lawns, or a big one is dog parks, where they will gather fecal coliform, and then they discharge to our waterways and they pollute our waterways. There's lots of different types of surfaces. There are some folks who think that grass vegetated swales that have turf grass are solutions. Really not. When you mow grass and keep it low, it forms very shallow roots that form a mat, and there's very little infiltration. It runs off very quickly. And similarly, there's usually, that's where people let their dogs go to the bathroom. Sometimes they don't pick it up. Even when they do pick it up, if you have dogs, you know that you never get all of it. There's a lot of other things going on there that create this pollutant. So very common pollutants are nutrients. That's primarily NPK. Nitrogen, phosphorus are the two biggest ones that will cause algal blooms. Those come from a lot of different sources, but people putting in fertilizer in their lawn is one of the most concerning ones that we have. But there are lots of different types of nutrients that get washed into waterways and cause eutrophication. Metals, things from cars, brake pads, roads, all sorts of metals and toxins metals in toxic concentrations will wash from roadsides in particular into bioswales, and then into stormwater drains, and then out to waterways. Bacteria from fecal coliform is a really big one, coming from a lot of different animal feces. Sediment is, it runs off asphalt, off of roof tiles, off of just dirt that is being accumulated. Gouges sediment, and the sedimentation is obviously a huge issue that we have because it carries pollutants as well as changes the flow of water. Hydrocarbons, we'll talk a little bit more about some specific organic and carbon-based compounds, but hydrocarbons, just any kind of plastics or oil get washed in, and obviously those cause problems. And then the one that we're going to be talking about today, toxins in fish, a few specific toxins. So I'm taking most of this from the fairly recent Toxins in Fish implementation strategy that was just released. If you have not read this, I strongly recommend it. The appendices in particular have a lot of great grounded approaches to implementation and really concrete next steps. I think knowing that we're coming from conservation districts and we're all stormwater implementers, I think you may share some of my frustration sometimes that it seems like we have a lot of research and kind of not really tangible next steps. This has a lot of really tangible next steps. But the four that we're going to be talking today are PCBs, PAHs, ECDs, and 6 PPD. I'm actually going to take a second if someone wants to unmute. I have been calling this quinone. Does anybody have a better pronunciation? Because I just realized I think I'm saying this out loud for the first time rather than the memo or an email. If somebody does, put it in the chat.
Yeah, if somebody wants to unmute themselves who feels comfortable by raising their hand, we can make sure that you're unmuted to say it.
I would love to hear from somebody. I have primarily read this and written it out. I have not actually said this out loud very many times.
I believe it's quinone, like quinine water, but quinone.
Quinone. Okay, so like a gin and tonic, but much worse. Good to know. Okay, so 6 PPD quinone. So PCBs stands for polychlorinated biphenyls. This comes from rubber, paint, oil, and motors. Road paint is a really common one. This is also a a common pathway for phthalates. Newer paints, the ones that are supposed to plasticize, contain phthalates, which are a really a bad toxin for fish as well. You see a picture here on the right of this paint chipping and eroding away. This is a really common pathway for it. Oil, obviously, we have a great don't drip and drive program that focuses on oil and making sure that you have tune-up so your car isn't dripping. We often tell people, hey, if you really want to contribute to that, keep your car in your garage. I know a lot of us treat the garage as overflow storage, but if you keep your car in your garage with an oil pan under a specific parking spot, you have a much higher chance of catching those drips and stopping oil from running off down your driveway into your storm drain. So those are two sort of things, but obviously we are not municipalities. There's nothing that we can do about chipping paints, except telling people, hey, why don't you clean this up? Why don't you use something new or some kind of sealer? But these are very difficult. I'm going to share something that's not on here because I could not find the source that I had originally read this in, and I don't want to put information out there without a disclaimer when I can't find the source. But one of the things that is so toxic about PCBs is that they accumulate in fatty tissue. And so they are very susceptible to biomagnification. So these things are toxic, but they accumulate in higher orders, and they're directly responsible for some of the toxic syndrome that we see in orcas, because they accumulate in fish fatty tissue, and then they are obviously biomagnified in orcas, as well as other protected species such as the bald eagle, which predominantly hunt salmon. Take that with a grain of salt, because like I said, I read that a year or so ago, and I'm not able to find the source. If somebody would like to correct me, or if somebody knows the source I'm talking about, that would be great. We can talk about that at the end. But I did want to mention it with the caveat that I don't have a citation to back that up at the moment. PAH is polyacrylic aromatic hydrocarbon. Anybody who has a wood-burning stove or a pellet stove will probably recognize creosote. This is something you have to get your chimney cleaned out every. Oh gosh, I don't want to tell you how. I'm not qualified to tell you how often to clear out your chimney, but periodically. One of the ways that is most common for us to interact with it is with these railway pilings. These are still really common retaining wall material. And they still get used, especially in some older municipalities, along roadways. And when it rains, it just starts to sap small amounts of that creosote out of these boards. And as they crumble, because they're all falling apart, more and more of that material is washing out and into the storm drain, especially if they're washing out over a lawn or near a sidewalk. There's nothing there that's going to actually stop this stuff and pull it out. Now, that is not the only place you're going to find this. It's also specific to roadways. You're going to find this in vehicles. Tailpipes that have, how often do you clean your tailpipe? You probably don't. But any sort of exhaust, any sort of carbon burning exhaust avenue, be that your tailpipe or your chimney, has an opportunity to have creosote. And has an opportunity to leach that amount, or that gas, which then will condense on the roadway. So another one to look out for. And as you're out walking and you notice any of these railway piling retaining walls, maybe flag that as a potential new project site. I, as a private landscaper, did a lot of these replacement projects, and there are a number of places that will accept these as reclaimed lumber. It costs a little bit more, but some kind of incentive. Usually people who have these, they're not excited to have them because they're slowly crumbling. So that is an area that can be targeted for some kind of future project. EDCs, these are commonly from pesticides. they rather, when they appear in stormwater, they're commonly from pesticides. They're not as common in stormwater as they are in wastewater. There are other avenues for introduction to water, primarily come from wastewater. We're talking about stormwater because stormwater is one, what we work in, and two, has a higher chance of going untreated. So this is primarily done primarily occurs in places that have lawns that require high inputs, or gardens that ornamental gardens that require high inputs, where people are putting down pesticides in order to maintain their nice ornamental hydrangeas, or in a lot of cases urban agriculture, which breaks my heart because urban agriculture is a huge passion of mine. And it always bums me out to see somebody who's probably trying to do the right thing and has probably heard like, oh, you got to put pesticides down in order to make your, to keep aphids off your tomatoes or something. But they're doing something that ends up being very harmful. So again, when you're putting together any kind of implementation, you're thinking of these kind of gardens, you're thinking, we have to also be messaging not to use pesticides. But if you're looking in an area where that's not feasible, that could be another great opportunity for a project. I mentioned on here this is residential and rural focus. It's less rural. I'm focusing more on residential. Rural has a higher capacity for green belts and filter strips, and they're also working in quantities that are very different. Residential gardens are a little bit more low stakes. You can, if you go up to someone and say, hey, you need to stop using pesticides, it's not necessarily going to affect their bottom line. They might be more open and accepting of that information. And we have different toolboxes in residential areas like GSI to mitigate them. And so in 6 ppd quinone, no, I said it wrong. 6 ppdq comes from tire rubber. It's this is new information that we're all kind of still processing here, carried by stormwater from driveways and roadways. It enters waterways primarily from outfalls if it's not been treated. I've seen, this is another one I'm putting an asterisk on, I have seen some information suggesting that once it hits water, it spreads out. It is hydrophobic, so instead of remaining concentrated, it immediately dilutes itself, which would be good, except that even in small amounts, it seems to have a pretty significant impact on pre-spawn mortality. If anybody is wondering, why are you showing a picture of the organic compound structure that it is when you show other things? At the last minute, literally about 15 minutes before we went live, I had a picture from a pre-spawn mortality survey of a coho that had died, and we had cut it open in order to show that it hadn't spawned. And at the last minute, I decided, I am the last presentation before lunch. I don't want to do that to you folks. So I swapped it out. If you are interested in any of that stuff, please let me know. SCD is actually working in partnership with King County on some of those surveys. We would love to share some of the results of those with you. There's lots of very interesting information coming out of not only pre-spawn mortality, but where the pre-spawn mortality is happening. But in case anybody is thinking about eating in the next half hour, I wanted to spare all of that. I wanted to spare you all of that.
David, not to interject too much, but just if you've got a web link, I'm happy to put it in the chat so it gets to everybody that may go to some of those materials if you have one.
Oh yeah, I'll tell you what. While we're answering questions at the end, I will pull together some of my links, and if I cannot get them out before the end of this presentation, I promise that I will submit them so that they can be emailed out at the end of the day, so that everyone has access to the citation.
Sounds great.
Great. So we've done the doom and gloom. This is everything that's wrong. This is all the terrible, scary stuff. Actually, I'm going to back up for a second, because the thing that I want to really highlight about 6 ppdq is that since it comes from tire rubber, it is ubiquitous to every single roadway and driveway. there is not an area that does not have a small amount of tire rubber. There are definitely areas, and our riparian friends can attest to this, where like there are old tire not retaining walls, but like bumper walls. And there are definitely some areas that can be highlighted, higher traffic areas. But every single, if somebody parks their car in their driveway, if somebody's driving on a road, they are leaving tire rubber behind. So this is not only a very impactful toxin because it is causing pre-spawn mortality. It is hitting individually, or it is hitting really sensitive populations. Dying before they can spawn is very, very scary. But it has an enormous impact on the population, but it is also ubiquitous. So before I've mentioned, you can look for this and kind of think, oh, this is a good area for a project. You can look for this, you can think this is a good area for a project. This is everywhere. Anywhere that you can get a roadside garden in is going to help remediate this issue. There are some higher areas. If you can look for, higher traffic roads, that is definitely a good tactic. But you kind of can't go wrong with looking for places to remediate this issue. So I want to talk a little bit about the difference between bioinfiltration and bioremediation. So bioinfiltration is a lot of what we kind of traditionally know as rain garden, as GSI, rain gardens, bioswales, constructed wetlands like Mike was talking about earlier, and then wet ponds. The idea is that the soil's water is retained and then slowly infiltrated past the either native or engineered soils, and then into native soil, back into the groundwater. And the important part about that is that the soil structure is what's actually doing the filtering. The soil structure is and the soil biota are retaining retaining and filtering the toxins. They aren't necessarily remediating them, but they are filtering them through the normal groundwater process so that the water that is discharging down is cleaner. That's about as far as I'm going to go in terms of the explanation, because I'm not an engineer, and I don't want to try to get too technical and get it wrong. There's a lot of discussion around this. The Stormwater Manual has a lot of great information. The Washington's Stormwater Manual has a lot of great information about this actual process and the best management practices that go into it. But I want to differentiate it from bioremediation. Bioremediation is a process by which vegetation and topsoils are the ones that are filtering the sediment. You pick plants and you engineer soils that will actually take up and utilize some of these toxins, and will actually remediate them so that they're not an issue to be handled later. The vegetation in this performs a couple different roles. It actually slows and disperses the flow of water that primarily happens in bioswales. It's something that we commonly call complicating the flow. If you can think about a path being very straightforward and then a path winding back and forth, the second path is more complicated. We want the flow to be complicated because the longer it is in an area, the slower it moves and the more circuitous path it has to take, the higher chance that it is going to infiltrate into the soils rather than run off into an outfall somewhere or another waterway. And where that waterway may not be engineered to handle the toxins and pollutants that are in that water, the bioswale or the bioremediation cell is specifically engineered to handle those toxins. So it's an idea of primarily filtration that is going on. You're trying to keep things in residence, and you're trying to actually remediate, remove, process those toxins out of it. Now, it's not going to work for all of them, and in some cases, you are just going to have to kind of make do with the toxins are in this cell and they're not out in the waterway. But it works for a surprising a number of them. I don't have a lot of data on 6 PBDQ and what remediates it best. But we're going to talk about some other plants suggestions that I'm going to speculate on a little bit based on the research that I have seen. Another important part of this is topography. You need a lot of, I'll talk about the project that we did and why we picked it, but a major reason that we picked it was the slope and topography already existed for water to flow into it and it to be held in residence. And we weren't creating all new topography. If you are creating all new topography, it needs to be on roadsides. It needs to be sloped in a way that it allows for water to flow in and stay there, but it still needs to be graded in a way that allows that keeps it from becoming flooded, so it still allows water to flow. And a lot of those are very site-specific kind of measurements you need to take. So roadside gardens, what we're just talking about, they are constructed in the ROW, or right of way. As you can see, those are areas immediately adjacent to the road that are still owned by the city, but are on or adjacent to private property. The topography is a huge part of this. You want to make sure that you're increasing capacity for an existing swale or ditch, but that you're also following its current topography, so that water is still flowing in the direction that it wants to flow. That way you don't get standing water pooling or flooding in areas. This is why we have so far primarily done swale and ditch retrofits. We go into grass ditches, drainage ditches, and we say we're going to skim some of this off. You can see us taking this out up there in that top picture. And then we say we are going to, excavate a small amount, put down the RGM you can see on that right-hand picture, and then there on the bottom, you can see what it looks like once the mulch goes down before we actually put the plants in. So water is still running through that. It's running through it the same way it has been, but whereas before it was entering that swale and rushing off very, very quickly over that turf grass and then onto the local waterway, in this case, which is Perrinville Creek, and causing that waterway to flood and erode and become more polluted. Now most of that water is entering that swale, soaking into that rain garden mix and staying in residence. And it's only when we had really huge, those over December, those massive rainfalls, that water, once it entered, really started to flow over the surface the way that it had been before. So as I mentioned before, I'm going to talk a little bit about planting for roadside gardens. One of the things that you really want to maintain when you're planting anything on the roadside is visibility. You are next to a road. In any corner you have, you need to make sure that it is visible. I am speaking from experience. There is a fully blind corner that I have to drive about every day to work, and I love plants dearly, but there's not a day that goes by that I don't think about going out there with a shovel or a weed whacker, just so that we can see a little bit easier around this corner. So a lot of GSI people like to get big shrubby woody plants, which makes sense. They take up a lot of water. They help systems run great, and they're fairly low maintenance most of the time, but they block visibility. Your municipality will not thank you. The homeowners will not thank you. You really want to make sure that visibility is the key thing. Another thing is maintenance. Consider who's going to be maintaining these gardens. Municipalities often rely on us to maintain the installations that we do. So I am thinking about my crew, and are they going to be pissed at me when I send them out year after year to maintain something that's a real pain in the rear end? Or are you turning this over to a municipal crew? Are they going to be able to maintain this? Are they going to know how to maintain this? What kind of training is going to need to go into it? Is there a plant community that you could plant instead, so that they have an easier time with maintenance? Bioremediation, plants that will remediate these best, as well as plants that will handle the pollutant best. We did a depave project that when we did it, we didn't understand how much water was really going to be going into this thing. We did sizing, we did engineering, we did a whole suite of mapping exercises, and said, yes, we can confidently say that there is this much. But what we didn't know is that just a little ways north, the whole thing filtered, a whole massive impervious area would filter down because the catch basin that they had further north just did not work. So it was very common that catch basin in a heavy rain event immediately became overwhelmed, and the rest of the water would flow down to our system. It's flowing over asphalt, all this impervious surface, and it was totally overwhelming this little garden. That at the time that it first really got hit was like a week old, and I went back the next day after it had really been inundated, and I just started digging plants up because I was like, these aren't going to work. Never mind. And I dug a bunch of the plants up, and I just replaced it with almost entirely grasses. I said grasses, the grasses that I picked, these are really hard to kill. They are going to handle some of like the oil and stuff that is coming in way better than some of the nice flowers that I had, and even some of the woody shrubs. I said these are a lot hardier. They're going to be a lot more harder to kill. They're going to be a lot easier to maintain. Thick with hubris was like, never mind. I have to toss out my entire planting plan and basically start over. And the garden still works great. We still get compliments on it, which we thought everyone was going to hate it because it wasn't working as well as we thought. But once it grew into it, people really came to love the amenities that it provides. So thinking about bioremediation, not just what is going to handle this, but what is the toxin load going to be? Is this thing going to be, is the whole area a pollutant generating surface? What kind of, there was like an auto wrecker up the way, and so we got way more like oil and hydraulic fluid than we thought, like brake pad dust than we thought we would. So our poor little blue-eyed grass and camas just could not cope. And we were getting way more water. So as with everything toxic, it's not just what, it's how much. So for recommendations, I really suggest grasses. Grasses are very easy to maintain. If a road crew comes through and hacks everything down, they just know, listen, we just got to take a weed whacker and hack all this stuff down. It's going to be okay. They will come back. They may not do that if they hit your lovely red osier dogwood with a weed whacker and take it off. It may not be able to come back. But grasses are very hardy, and they will almost always bounce back, and they can handle being inundated. And as long as you pick the right species, they work very well. I will give you just some that I've learned since I've been doing this. Carex are a really common species for grasses here. I don't suggest them for GSI. I suggest clumping grasses in plugs on fairly close centers rather than spreading grasses, because soil in the engineered soils that are common to roadside gardens and GSI in general is very nutritious, and spreading grasses will take it over very quickly. We have had to go out and rip Carex out and plant something else on gardens that are just 3 and 4 years old because the Carex just takes over. So I would suggest that instead of doing the typical, like what my restoration instincts told me to do, which is get gallon pots of this grass that I know will spread and plant it on like 3-foot centers, plant them on much closer centers and just get plugs. And get plugs that aren't going to grow up a ton, and get your coverage that way. It will save you in maintenance in the future. No or few shrubs. We did plant some shrubs, but we did it with the homeowner's express permission, and we'll talk about working with the homeowners here in just a second. But with the homeowner's express permission, and we did it on their side. We didn't do it on the roadside. So if you can imagine a ditch, there's the roadside and there's the home side. We did it on the home side, and we did it because we had cut down so much that they were feeling a little bit exposed. So we said, we'll plant it, over here. These will grow up. They won't shade the garden out too much, but they'll provide a little bit more privacy from their side. So I do think that shrubs are appropriate. You just have to be careful about where you're going to put them. I would always suggest putting them on the slope or upland, not necessarily in the bottom of the swale itself. And then with most GSI, especially roadside gardens, you are going to be dealing with full sun almost all of the time. If you have a large tree that is overhanging, note that we had a couple large trees that were shading out portions, but most of the time, these are going to be full sun plants. And you have to remember that these are going to be moist to dry soils. That narrows your plant list down by a lot. We tend to think, right, rain garden, wet, things that will handle wet, great. I'm going to find some wetland plants. Probably not going to work. One of the reasons that I suggest grasses is because we have a wide range of grasses that handle both moist and dry soils. Your soils are necessarily going to be well-draining soils. And in the summer, I just realized I'm about to talk about in the summer. We are in summer and we've been hit with a couple really wet days. But most of the time, under more normal circumstances, in the summer, you are going to get very dry soils, and you need plants that don't need to be constantly watered in order to survive. You want them to be adapted to our flood drought cycle. You want them to be comfortable when it's dry and comfortable when they're inundated. And you want them to be allowed to be inundated for up to 48 hours at a time. Gardens, rain gardens, bioswales, all of that stuff should be draining in about 24 hours. But with some of the rain events that we've been getting, it may take closer to 2 days. So you want plants that are tolerant to being inundated periodically and okay with being very parched and dry for months on end. So let's talk a little bit about lessons learned. I used to work with a guy who said that the only experts are people who have made every mistake within a given field. And in that way, I feel like I am an expert on at least a few things. So let me share these lessons with you so that you can be an expert faster and make all new mistakes and you don't have to repeat mine. So this image you have down here at the bottom is a great top-down view of the engineering that went into our garden. You can see here, can you guys see my mouse?
Yes, we can see your mouse.
Wonderful. Okay. So this down here is the right-of-way boundary. So this area here is the right-of-way. So we kept all of our gardens within the right-of-way. But you'll notice that here and here and a little bit here, we had a few neighbors who said, you know what, why don't you bring this garden in? I would like to have a little bit more of this in my front yard. Now, I just called out that this is the right-of-way and that we didn't leave it. But you'll notice that I said we had a couple neighbors who said, I would like this in my front yard. The first and possibly most important lesson is that these folks really think of all of this space as their front yard. You know, these lines don't exist on the ground. What they have is their house and their driveway and their lawn and the street. And they don't recognize the area before they arrive at the street as anything but their yard. And that kind of brings me to my first point about outreach. We made the mistake, and I do say it was a mistake, and we corrected it. Before anybody gets too concerned, we corrected it in a dramatic way. But we made the mistake of doing kind of very general outreach and telling folks, hey, all these folks along here, we're going to do this project. We really hope that you like it. Why don't you give us your feedback? And when folks didn't get back to us, we thought, well, that's okay. You know, that's all right. They wanted to, they're not interested, or they didn't have anything to say, and we don't want to pressure them. That's fine. But I tell you what, as soon as we started having some issues, which, after a pretty massive rainstorm that December, these gardens here, in particular this spot, there was some standing water. And if you build GSI, you know that that's not strange, that there is standing water after a big rain event, and it takes about a day for it to come down. But these folks here didn't know that. And the folks that we had previously not heard from, suddenly became very, very vocal about how not happy with the project they were, because they now had standing water. And we immediately snapped to, and we went out and we asked them how we could reorganize things to make them happy. They gave us some suggestions for things that would make them happier. So we readjusted it, we changed some things, we did some different plantings, we just made some modifications so that, they knew that we were listening to them and that they were a little bit more comfortable. And while we were doing that, we were explaining a little bit more of the things that ideally we would have been explaining when we did our initial outreach, and when we had these conversations with them about what this process was going to look like. Things were occasionally a little bit heated, but we stuck with it. And now everybody is on the block is perfectly happy with it. People from different parts of the block come by and talk about how beautiful it looks. We even, and I'm not touting this as something you should expect, but we even got an apology letter from one of the residents about how upset he had been, which, while nice, is also understandable. He thought that something had gone really wrong. So I want to just impress upon everyone that if you do any of these projects in the right of way, consider that the people that you're working with do not necessarily see that as the right of way. They see that as part of their home. So that's outreach. Permitting, this was we were very fortunate. We were working with the city of Edmonds, and they were handling a lot of the permitting and doing this work in the right of way. Permitting the right of way can be very difficult. If you have the opportunity to work with a municipality who can make that who can make that a little bit more painless for you, strongly recommend it. Traffic control. This is one that actually snuck up on me a little bit. We had to close off a large area in order to do this project. You'll notice that there's no sidewalk here. So we had to close this area off, and we knew that when we did that, we were going to put this street, which is normally two-way, down to one-way. What we did not anticipate is that people who commonly walk this way with their strollers and their dogs as part of their normal walking route would, instead of picking a different route, just also use that one lane of traffic. So now you've brought the street from 2 lanes down to 1 lane, and that 1 lane is shared between cars and pedestrians. Fortunately, things were moving very slowly, and we had the city out there to put up signs for us and make sure that everything was controlled. But when that happened, I immediately thought, man, if folks don't see this coming, that could get really scary really quickly. Similarly, when we were pulling in equipment and materials to do a lot of this, or hauling out stuff, we were blocking, a sizable amount of the road. And in some cases, we were blocking the road entirely. Now, we were able to kind of guide people around, if our big dump truck was there and we were tossing sod into the back of it and people were getting ready to, trying to come down, we could say, hey, sorry, you have to go around. They go 1 block south, and then they're fine. It's really not a big deal. But for the people who live here, nobody got trapped, but there were a couple times where we thought that they might, because we needed to get the full load out, and there was a chance that we would actually trap them in their driveway. We were able to work around it, but that would have been another excellent way to really just not endear ourselves to the community, is not working around other people's schedules. And then, of course, planting. Like I said, we really went into grasses. We tried to avoid a lot of flowers and shrubs, except when we talked to people and they said, yes, I really would like some shrubs in order to in order to kind of regain some of this privacy. I want to reiterate before we move on that everyone is very happy now. This was not a permanent issue. It was just sort of a lessons learned moment that we had, and it was an opportunity for all of us to engage with the community and really do some extra education. As a last thing, this is my own little plug. I want to suggest that when you do, when all of us do outreach around gardens, we really start showing them photos like this. These are photos of gardens while they are working, and you'll notice that they have standing water. They are currently accumulating water. They are probably not yet infiltrating too much water. The reason I want to make a plug for this is that I find a lot of images, including my own, that show these gardens while they are in full bloom in the summer, while they are dry. And I believe that that is part of what led to a misconception as to what these gardens look like when they are working, because people see this and they go, oh my gosh, the garden has flooded. And no, the garden is working exactly the way that it should be. And we know that, but people that are engaging with this stuff for the first time may not. So that's my little TED Talk plug there. I want to say thank you to the Washington State Conservation Commission, Puget Sound Conservation Districts, good old PSCD. Our funding came from the Department of Ecology. It passed through grant from the Environmental Protection Agency. The work was done by the Veteran Conservation Corps. We actually have a presentation about them later on. And of course, Snohomish Conservation District. As I mentioned, the Conservation Commission performed some of the initial planning funding that we did. Grants came from the Department of Ecology and the Environmental Protection Agency, and the City of Edmonds also dedicated a ton of their time to helping us in reviewing this project. Okay, cool. I was shooting to leave about 10 to 15 minutes for questions.
That's perfect.
Wonderful.
Steph, I believe there's a few questions in the questions box. Do you want to go ahead and ask those first ones?
Yeah, definitely. So the first question is from Megan Martin, and she asks, do you have a reference for plant types that are ideal for these?
For plant types? I kind of have my own list, and it's pieced together from a few years experience. I was an implementer. I was installing these long before I was planning them, and then maintaining ones and repairing ones long before I was planning them. So I got a great kind of up close view of what works and doesn't work. But the two primary sources that I look at for us is the Snohomish County Drainage Manual has a list of bioswale appropriate plants species. They actually just updated it, and I did part of the review, and those are good. And then to a certain degree, the Rain Garden Handbook for Western Washington. I say to a certain degree because there are some plants in there that will not work in a bioswale, and so you have to kind of approach it with a really a very cautious eye and think really carefully about whether or not they're going to be suitable. But those two publications are the ones that I primarily use. If I were going to suggest things for other people, I would suggest the King County Native Plant section and a website called Great Plant Picks for the Pacific Northwest. They have very good rain garden plants as well, and the King County Native Plant Guide works for most of the Puget Sound region.
Awesome, thank you. So Vanessa Lee, or Lay, sorry if I'm mispronouncing those, she left a comment around 11:15. She said, I'm currently a Wazoo environmental student, and they talk about PCB bioaccumulation and magnification in multiple environmental classes. She also said that she's a veteran conservation corps member.
Oh,
so those are just some comments.
First off, thank you so much for being a VCC member. You guys are fantastic. I'm so happy about that I will let go that you come from my rival school. No, I'm joking. if you, sorry, and actually thinking about WSU, there is a book called Grow Your Own Native Landscape. To our last question, I cannot recommend Grow Your Own Native Landscape enough. I actually hand it out to almost everybody I do a site visit for. It has a really wonderful plant list in the back, but it's not just a great plant list. It also gives you more information that I think you will find short of POJAR as to plants, environment, and utility. If you are involved in any of the environmental horticulture, field, restoration ecology, anything, strongly recommend you pick that up. And I also want to apologize. My references for anything east of the mountains are very, very lacking. And that's not intentional. I work on this side. So I'm happy to, if anybody has resources that they can share for east of the mountains, those would be wonderful. I would be interested in those as well.
Great, thank you. And I think I just found those as well, that book you recommended, and added a link in our chat if anyone wants that. I'm not seeing any other hands or questions. Kelsey?
I have a question. I'm always filled with questions. David, I was wondering if you'd be willing to just kind of like elevator speech wise, walk us through the timeline of one of these projects, like from securing the funding for, once you identify the need as it relates to the program priorities of your district, like securing funding, kind of all the way to that, it's installed, you're reporting on it, and then you've got a maintenance plan. Like, what type of timeline should folks be expecting when they're engaging in this kind of work?
It really depends. So I would say that you don't want anything shorter than a year. And the reason you don't want anything shorter than a year is that there are specific things that you are going to do in specific seasons. I shoot for all of my grant funding to be a minimum of 2 years, because I like to be able to do 1 full year of research and outreach to determine not just where the high need areas are, but where the interest is. Because as you all know, we can't push these projects on anybody. We have to get them to want to do it. So but to look at it over the course of a year, from January to March, you kind of want to be figuring out where you want to work, and you want to be doing outreach to that area. It's wet, it's rainy, people are thinking about the rain, so it's not a bad time to be doing it. Once you have an area that you want to work in March, maybe in April, you want to be putting together the contracts, and you want to be working on the designs. There's a little bit of a chicken and egg thing on contracts and designs. We have a phenomenal engineer, Derek Hahn, who can toss one of these designs together very, very quickly. And we use those designs as kind of a little bit of a carrot to get people involved. Like we say, we're gonna do this cool design for you. And then when they go, oh my gosh, that is a cool design, we go, yeah, please sign this agreement to let us build it for you. And we kind of try to bring them in a little bit like that. Other times, we have started with the agreement, and everybody's on board and says, yes, we're gonna do this project, and we go, great. And then we move forward with the design, and the revision of the design is something that is eventually initialed. They say, yes, this is the design that I want. We only do ground disturbing activity when it is dry enough to do so. That's funny right now, because we started our ground disturbing activity in May, thinking that it would be dry enough to do so, and our site has been dumped on at least 3 times. So we shoot to have our construction season around June to maybe the end of October at the latest. We shoot maybe towards the end of September. So in that kind of 4-month period is when usually it's dry enough that we feel comfortable working with the soils. And we're comfortable doing the excavation, doing the backfilling with the RGM, and then mulching over the top of it. Now, depending on when you do the project in that period, the project is going to sit there for a little bit. And the reason that we have them sit there for a little bit is because we like to do our planting in in the fall when it starts raining again, because it gives us a higher survivability rate for the plants. That is also, that planting event is also usually tied to some outreach. We invite people to come out and plant. We have, like in the before times, we'd have big tents set up, we'd get volunteers, and then that's kind of a chance to say, look how cool these rain gardens are. Don't you want one? And then you get started on the out, in October, you're getting started on your outreach for next year. As you said, a quick elevator speech version of it.
That's great. I think Bill actually asked a great follow-up that kind of went in my mind, which is, how do the permits fit into that timeline?
So in this case, if you're doing right-of-way gardens, your permits need to be through the municipality, or your permits will be through the municipality. In this one, we are fortunate to also be doing to be doing this on DOE funding. So our permitting process with the city was happening concurrently with our planning approval through the Department of Ecology. So we were reviewing plan sets on both ends at the same time and making those updates at the same time. If you're doing that, then the city is one of your partners, and the city should be the first place that you approach about where this project could happen, and they should kind of be the start of that process right when you know you have funding. I am actually hesitant sometimes to even apply for funding if I don't believe that I have a city kind of in the hopper that wants to partner with this. Funding comes up, I say, this is something that we could do. I talk to 1 or 2 cities that I think will want to do this project with us. And then part of that application is we're going to work with this city. We have some areas that are possibly highlighted. Here's their letter of support as part of the grant application. And then as soon as we get that funding award, we can go back to a planning process with the city.
Great, thank you.
And sorry, and to directly answer Bill's question, with that much lead time with the city knowing that it's coming, you should have a really clearly outlined permit process so that you can be putting stuff together beforehand to try to make that, just like we do with cultural resources or any engineering, you have stuff really laid out ahead of time.
Great.
Thanks, David. Yeah, I was thinking generally it's a right-of-way permit, right? And then a grading possibly on the amount of yardage. So it's not a real big complicated permit. It's just making sure you get those a little bit ahead of time, right? And maybe some fees, but usually not. Is that how it works?
We haven't incurred fees yet, and part of that is that we're not a contractor, and so folks are usually a little bit okay. Cities are a little bit okay with us kind of with them not applying fees. We also haven't, and this is just in Snohomish County, but we haven't ever exceeded the lower boundary for grade and fill on a GSI project. So we haven't had to deal with that yet. I take that back. We have through one of our partners. Our partner put together the plan. They exceeded it. They were the ones that went out and got the permit. We assisted in putting that permit together, but we have not yet done a project so large that we have had to be the principal on seeking that permit. And again, because we're partnered with the cities, usually doing this on city properties, they are very engaged in the process and be willing to kind of help us out.
Great. Well, it looks like we're right at lunchtime. David, thank you so much for your presentation. It was really insightful and helpful. Bill, do you have any final words?
No, you did great, David. Thank you very much. You did awesome. That's exactly what a kind of message I wanted to get out there. And I know you're a good resource for everybody.
Yep, my information's on there. Please feel free to reach out to me with any questions at all.